In this video, we will see the derivations for the multiplying factor and the resistance in case of voltmeter and the ammeter. To increase the range of ammeter, so resistance is connected in parallel. So what is multiplying factor? Multiplying factor is the current you desire to measure and the actual rating of the meter. So here you can observe that current I is this V multiplied divided by RSH in parallel with the RM, and current IM is V divided by RM. Here this gets cancelled, so RM will go in the numerator and the RSH is in parallel with the RM. If you solve it, if you write the formula for the parallel combination, you will get this one. Now if this RM and RM get cancelled, RSH plus RM will go upward and this is RSH. If you solve it further, you will get M is equal to 1 plus RM divided by RSH. If you again solve it, then here M is there, so M into RSH minus RSH is equal to RM. So RSH, if you take RSH common here, then it is M minus 1, so RSH is equal to RM divided by M minus 1. So these are the formulas for the shunt resistance and the multiplying factor M. So M is equal to 1 plus RM divided by RSH. If you remember this thing, then you can calculate this. So let us find the multiplying factor and the resistance in case of the voltmeter when you want to increase the range of this voltmeter. So resistance is connected in series to increase the range of the voltmeter. So what is multiplying factor is the voltage you need to measure and the capacity of the voltmeter. So what is V? So V is input this voltage, that is equal to IM is the current flowing through the circuit, so that is equal to IM into RS plus IM/RM. And what is VM? VM is this one, IM/RM. So here you can cancel this IM, you will get RS plus RM divided by RM. So that is equal to 1 plus RS by RM. So here also, if you take this RM here, you will get MRM is equal to RM plus RS. MRM minus RM is equal to RS. So RS is equal to M minus 1 RM. If you write M is equal to V by Vm into RM minus RM, here we have multiplied with the RM, MRM minus RM, so M is V by Vm. So here RM by Vm is Im, so you will get V by Im minus RM is equal to RS. Many times RM is very small, actually RM is very small than the RS, so RS is equal to V by Im. So series resistance is very much greater than the meter resistance, and in case of ammeter shunt resistance is smaller, is having the low value than the meter resistance.